Hi, I'm David Andine, Director of Business Management here at Maxim Integrated. And today we're going to talk about the CAN protocol, or the Controller Area Network Protocol. Joining me is Bob G., Executive Business Manager. Bob, thanks for joining me today.
Dave, glad to be here.
So Bob, when we talk about serial transceiver protocols, people are familiar with RS-485, CAN. What are some of the historical items and trends that you might want to mention today?
Sure. So CAN bus standard was originally developed by the Robert Bosch company, and that was targeted for, obviously the automotive space. And BMW was the first car company that actually adopted CAN bus, and they saved a ton of weight because it was reduced cabling as well as connectors, and so really took advantage of that CAN bus protocol. And we're beginning to really see an uptick in terms of adoption in the industrial space. So we're seeing companies who manufacture drones, e-bikes, elevator controls, just to name a few.
Wow, sounds like CAN has a lot of momentum right now.
Absolutely.
So let's dig a little bit deeper into the protocols and take a look at the demonstration that we have here today. We have two development boards hooked up to these oscilloscopes. The first one is an RS-485 board connected up to this oscilloscope, and the one closer to me is our latest CAN product. That's the MAX 13054A, and the evaluation board is actually an Arduino form factor shield. So Bob, first off, what can you say about what we're seeing on each of these boards?
So for this RS-485 EV kit, we can see that for channel 1, the probe is on your data line A, and the second channel, the probe is on your line B. So your line B is your inverting line, and your line A is your non-inverting line. And you can see how that is how you get your differential signal, and that they're opposite of each other, and it really plays out well in applications that have a lot of, let's say, electrical noise, and sending signals out differentially is the way to go. Moving over here to our CAN shield board, you can see how it's shaped a little bit different. So in channel 1, represented by this green line, which is on our CAN-H data line, as well as the second channel noted by this purple trace for our CAN-L line. And so you can see that the signal's still sent out differentially, but they're in a way like mirror images of each other. But it's still very robust and really suitable for applications that have that noisy environment.
And it looks to me like if you actually subtracted the high and the low signals, you're either going to get a 0 or a significant value. Is that right?
Absolutely, and that's the advantage of a differential signal.
Okay, so how do these two protocols compare in terms of termination resistance and data rates?
In terms of termination resistance, fortunately, they're both the same at 120 ohms. So there's one on the extreme ends of the network. But in terms of data rate, RS-485 has traditionally been faster. Maxim offers something that goes as fast as 100 megabit per second.
Wow.
The original CAN standard was not as fast, at about 1 megabit per second, but they've actually updated that standard. So now you can go as fast as 12 to 15 megabit per second. And with that kind of throughput and bandwidth, it should be able to cover a lot of industrial applications.
Absolutely. And then how about in terms of number of nodes and distance that the two protocols can cover?
Well, for RS-485, the number of nodes that's called out in the standard is 32. And for CAN, it's 30. But in terms of distance, 45 has been traditionally a lot longer because the standard calls out for 1,200 meters, whereas for CAN, it calls out for 40 meters. But Maxim has utilized the same IP that we have for the 45, carry that over to CAN so we can achieve longer cable runs.
Now, you also mention a lot of the same IP in both of these products. And I know that we have a lot of unique IP in our interface line around ESD protection and also voltage fault protection.
Absolutely.
And those are features that are also in the 13054A. So why don't we go ahead and have a little fun. Let's disconnect this board and do an ESD test and a voltage fault test. So we'll disconnect this board and run those tests right away.
Okay, sounds like a plan.
All right. So we've taken our MAX 13054A off of the oscilloscope back there and connected it up to a power supply on this board. We've also put a small smiley face on there so that you can verify that it's the same board that we're zapping here, and we'll put back on the oscilloscope for later testing. And we've got our 15 kV ESD gun here, as well as a 65 volt power supply. So Bob, are we ready to go to zap this guy?
Yeah, we're gonna have some fun. So this ESD gun is set for plus or minus 15 kV ESD air gap per IEC 61000-4-2. Zap it 20 times, 10 times on the positive side, 10 times on the negative side. So let's have some fun.
All right, let's do it. Okay, so we've just zapped this board a number of times with 15 kV ESD, and now we'll move to the voltage fault here. Okay, so what we've got is a couple of power supplies that we've stacked together to generate 65 volts, which you can see here. This is something that's very simple and you can go ahead and do in your lab without a lot of expense. And then we'll go ahead and connect these in, right?
That's right.
Connect the ground here,
Yep.
and then I'll connect to the CAN high line here, right?
Right. There you go.
Okay.
Yep.
And Bob, this is something that we can conceivably leave on the board for an indefinite period of time, right?
Certainly, and that's what makes Maxim products so robust, is that their fault protection is so high and it can withstand for a long period of time, and it will still continue to operate as soon as that high voltage is removed.
Fantastic.
Yeah.
Okay, we're going to go ahead and disconnect this board and reconnect it to the oscilloscope and show it operating again, hopefully. We've just performed our ESD test and our voltage fault test, and we've taken our MAX 13054A shield and reconnected it up to the oscilloscope. If you can see closely on the shot, you can see the same smiley face that was on the board. So it's the same board. And Bob, it looks like we've got all of the same signals that are passing through this CAN transceiver and this board, and so it looks like it's passed the test.
Absolutely, and that's what makes Maxim serial transceiver a leader in the market, because of that robust performance. We just zapped it with high ESD, we subjected it to high fault protection on the data lines, and as you can see, it's operating with no issues at all. I mean, that's the reason why customers like our parts and the reason why they choose ours over others.
Mm-hmm. Absolutely. Absolutely. Well, Bob, thanks for joining me here today. Mm-hmm. And thanks so much for joining us also. Please take some time to go to the Maxim website, where you can learn more about the CAN protocol and more about Maxim's products in the CAN space. Specifically, you can get samples for the MAX 13054A. You can also get the shield board and begin developing around putting that product into your project. Thanks so much for joining us here today, and we look forward to seeing you next time.